Hi, my name is Frederick, and in this 10-minute video, I'm going to give you a short introduction into the main deep learning challenges today. But first of all, what is deep learning? We know that everybody talks about deep learning. Nobody really knows how to do it. Everybody thinks everyone else is doing it, so everyone claims that they are doing it as well. But at the same time, the talk about deep learning has shifted in the last few years. So just a short recap of what has changed in the past 20 years or so. In the early 2000s, people were talking about if it can be applied at all. In the mid 2010s, people were asking what business problem can it be used to solve. And today we see that the question has shifted more towards how can we make it core business as quickly as possible. So there are three fundamentals in deep learning, and you know probably all of this already. You need large amounts of data. You need some data to train your models on. The second thing you need is you need processing power. You need something to use the data and run your algorithms to train your artificial neural network. And third of all, you need expertise. You need people who know how to build these models. All of these are in some kind of supply order today. Companies have been amassing data since the 70s, since the 60s on customer behavior and so forth in more traditional industries, and more leading AI first companies have been built with data gathering at a core. At the same time, cloud computing has enabled every company in the world today to basically amass any amount of processing power they need. The data scientist part is probably the one that's gapping adoption the most. We can see that, for instance, on Glassdoor.com, data scientist salaries are 20 to 30% more than their software engineer counterparts, for instance. But given all of these, there are a couple of other things that we see as the largest challenges in deep learning today. And let's go through all of these. The first one that we're going to look at for a recipe for a fast return on investment is experiment reproducibility. The second part is regulatory compliance. The third one is fast onboarding of teams. And the fourth one is quick experimentation. So that you should be able to get your results quickly, fail fast, build your models, and then finally come out with a real solution that works. So let's look at all of these in one at a time and see what they mean in practice. So experiment reproducibility. Um, you've all probably seen or heard about Uber's self-driving car that drove over a person a couple of months ago in the summer of 2018. Um, if Uber wouldn't have had reproducibility, or any car manufacturer for that sense wouldn't have reproducibility in their deep learning models, how could they ever learn, or how could they reteach those models to, for instance, not have bias? And this is a basic thing. I mean, a deep learning model experiment is a bit more uh, deep than a standard software engineering model, for instance. So deep learning model starts from you giving some input, you're executing the model, and finally having the model as an output. So usually as input, you have your training code, maybe written in Python, in Jupyter Notebook, or as a script and version controlled in GitHub. You have some parameters, your hyperparameters from epoch size to learning rate and drop-off rate, for instance. And then you have your data sets. And when it comes to deep learning, usually you have terabytes, if not petabytes, of image and video content that you train your deep learning model on. The second step is execution. So an experiment requires that you actually run your experiment on some specific hardware with some specific software libraries, basically a Dockerized container environment. And in order to reproduce the experiment, usually you need to know what it costs to actually run the experiment, so that you know that was it a $2 expense or was it a $2,000 expense to run the model. And thirdly, you get an output, you get the actual model itself with the weights and biases, with the log files of how the training was run, the results from the training run, and statistics from the behavior of the model itself. Sadly, however, a lot of companies still today uh, are not able to record all of these. So usually you definitely get the model itself with its weights and biases. And if you have a company internally well working methodology for using version control, then you'll definitely have the source code as well, for instance, in Git. But in many cases, people are running notebooks on their local machines and might not have version control for anything at all. They might just have the latest version on their own desktop even. The second part, which is regulatory compliance, um, you've all probably seen or heard about GDPR in the last year or two, even if you're outside the European Union. GDPR, in short, when it comes to machine learning or deep learning models, it's got 3 points. Those points being that an individual must be aware of automatic decision making. Secondly, the individual has the right to gain information about the logic behind the machine learning model. And thirdly, they should be able to deny the usage of automated decision making for them. The second point here is the most important one, that people should gain information about the logic behind the machine learning model. And I mean, there's different ways for doing this. There's no standardized way for verbally or even visually conveying the logic behind the machine learning model, but you could plot the model on a graph. You could visualize in a CNN network. You could visualize parts of the nodes and show the logic behind those. But at the end of the day, you definitely need to have the model, the training data that was trained on, as well as all the other parts that we mentioned earlier. The third one out of 4 is fast onboarding of teams. Usually people think about deep learning as a pipeline consisting of several steps. The first one being data storage and exploration. Then we start extracting data from the storage. Then we build our model, we deploy our model somewhere, and we monitor it in production. So in the first step, we probably have some databases, some Excel sheets, maybe some notebooks, pandas, and R studios. Then we do some extraction with some shell scripts or different kinds of scripts written in R or C++ or in Python. Uh, when we start building our models, maybe we use TensorFlow or PyTorch or Caffe or Darknet. Finally, we deploy them maybe on-premise or in the cloud. Most probably inside a Docker container so that it's easy to move around. And finally, we'll doing some kind of monitoring of the system, for instance, with New Relic or just looking at plain old log files. The challenge with this is that it's a lot for a single data scientist to know and to amass. So usually in companies, we have data engineers that are helping the data scientists doing some part of the orchestration of machines. And sometimes we have IT departments working there as well. But at the end of the day, I think we can all agree that it's a mismatch of non-integrated teams and technologies. Our forerunners in deep learning, the technology unicorns who are really betting on deep learning, like Facebook, Uber, Google, Airbnb, and Netflix, they've all seen these challenges. They've all built their own company internal tools. Probably, if you want to Google for something, Uber's Michelangelo is probably the most well documented or seen part online about how to do deep learning orchestration. So the last one is fast and quick experimentation. So let's have a look at that. I think we can visualize this the easiest by looking at software engineering. So we all know how software engineering has changed quite a lot and picked up speed in the last 20 years. If we compare, for instance, 2018 to 1998, in 1998, companies were probably able to deploy new software products maybe 4 times a year. And unfortunately, everything broke down always when we deployed a new product. In 2018, companies are deploying as much as 10 or maybe 100 times per day and virtually breaking nothing anymore. So what's changed? What's changed in these 20 years? There's a couple of things. Basically, it's all the tooling involved in around software engineering. So software engineers are using version control today. They have continuous integration servers like Jenkins, kicking off new workloads whenever something changes. For instance, software engineers have started encapsulating code into microservices instead of having one monolith system, and they've started using cloud computing, so it's easier to use the machines. But these tools are still missing from machine learning and deep learning. And we feel that if we were able to solve this part, we could move the data scientists from 1998 to today. So these four are the main parts uh, for getting a fast result. So what is then Valohai? Well, Valohai is a deep learning management platform. At the end of the day, what we want to do is we want to take you from this picture where you've only having the training code and the model itself, and take you here where everything is automatically version control. We take a snapshot of every training iteration that you do, and you always have a 100% audit trail back to what you've done previously. We also want to take you from this picture where there's a huge mismatch of different technologies into where you have working machine learning pipelines that are coordinated between each other. At the end of the day, we do reproducibility through version control. We do regulatory compliance through 100% audit trail, so you always know how everything was done. Uh, we enable fast onboarding through common ways of working, also different kinds of tools for sharing models between team members, seeing in real time how other team members are working or what they're working on, as well as how their models are progressing. And finally, quick experiments through machine orchestration. Automate as much as possible. With Valohai, you just click a button and you automatically train your model on, for instance, 100 GPUs without you having to SSH into cloud services or anything like that.
That's it. I hope you've learned something new. I'll post a link to the demo video below so you can actually see what Valohai looks out in practice. If you have any questions, just reach out to me at fredu@valohai.com. Thanks.